This is an introduction to NumPy in Python and NumPy arrays. Arrays are really important. They're a really important way of structuring data. You can think of images as arrays. They're essentially just arrays of data. They're arrays of data that we can see as an image, but they are arrays of data. And I find picturing arrays as an image quite a useful way of thinking about them. And we're going to be doing more on that later on in this video. Why NumPy? Why not just use lists? Well, NumPy handles arrays better than a Python list, and NumPy is very, very fast when it comes to handling arrays, which we will have a look at later on. So what I'd like you to do now is to write this line here, import NumPy as NP. Incidentally, this worksheet, this Jupyter Notebook, is available to download from my website. So if you want to follow along and write it in yourself, you can. Otherwise, go to my website and you can download it there. So import NumPy as NP. This way of importing NumPy into Python is, you'll see it a lot. NumPy is always abbreviated as NP. Sometimes you will see this from NumPy import star, which means import every single function from NumPy so that you can use it without having to write np dot. But this is generally not a very good way of importing stuff from a library, so we won't be doing it. Right, we're going to set up two different types of data structure here. We're going to set up a list and we're going to set up an array. They're both going to have 10,000 elements in them. So now we have a NumPy array with 10,000 elements and we have a list with 10,000 elements. What we're going to do now is we're going to go through each one of those elements and we're going to square that element. And we're going to time to see how long that takes. And we're going to compare the difference between doing it through a simple Python list and with the NumPy array. So here we go. And we can see here that for the Python list, it took 3.76 milliseconds per loop. And in the NumPy array, it took 7.58 microseconds. Now, a microsecond is 1,000 times shorter than a millisecond. So you can see what a difference that is. It's much, much faster using a NumPy array. Let's have a look now at that array that we created. Now, obviously, we're not going to see the whole array. We've got an abbreviated version here. But you can see we know it's an array because when we look at it, it says array here. And then it's between the curly brackets and then square brackets. And we have all of the elements from 0 to 9,999. And that's it. Now, this is a brief overview of NumPy. I just want to give you a feel for how it works. Here are some methods that you can use on NumPy arrays. So we've got myArray. If you want to know how many dimensions the array has, you can use .ndim. And this array has just a row. There are no columns there. It's just a one-dimensional array. And we can have a look at the shape, and that will confirm it. So we can see it has 10,000 rows and no columns. If we want to have a look at the size of the array, that's how many elements does it have? Well, it has 10,000. And if we want to see the data type of the elements, then we can look at that too. And we can see that it's a 64-bit integer. If you want to create an array, the simplest way of doing it is to create the variable name and then put that equal to np.array. And then inside the curly brackets, you have to have square brackets with the elements in there. Or you could put a list. For example, if you had list 1 equals, I don't know, let's say 5, 6, 7, 8. And then you could put another array equal to np.array, and then in between the curly brackets you could just have the name of the list. And if you want to see what another array contains, then it's the array with 5, 6, 7, 8 in it. If we want to have a look at the new array that we created earlier, that's 1, 2, 3, 4. In this overview, I just wanted to show you a few other things that you can do. Sometimes you might want to find methods and functions that have a certain feature. And you can do that by typing np.lookfor and then the name of the feature that you want it to search for. If you run that, then we get a list of results for linspace. As you can see, the first one returned is linspace itself, and then there are a whole list of others that contain that keyword. Something else you can do is if you're typing and you know that the function or method that you're looking for begins with, say, an H, but you don't know the rest of the characters, if you put the star character followed by the question mark, it will return down here. You can see all of the commands that begin with an H there. Another way of doing that is using the tab complete. So if you type np dot and then you use tab complete and then you type the H, you get that list. It's the same list there, and Jupyter Notebooks will give you the options there that you can choose from that begin with H. And I find that very useful. Another thing you can do is find out how something works. So if you can't remember how the histogram function works, then if you just type np.histogram followed by a question mark and you run that, Then down here, you'll see that we get the instructions on how to use this. Okay, let's move on now. I'd like to have a look at an image, and to do that I want you to go to this URL, which is included in the description below the video. It's also on my website. Download this image and make sure you save it to your folder that you're running Jupyter Notebooks from. Do that, put this code in. This matplotlib inline means that you will be able to display images inside the Jupyter Notebook and figures and plots and that kind of thing. And what we're going to do is we're going to read in this image and we're going to read it into a NumPy array. So now we have an image as a NumPy array. And as you can see, this is 8 bits. It goes from 0 to 255. For those of you that don't know, I'm sure most of you do, but 8-bit means 2 to the power of 8. So we've got now an image as a NumPy array. Let's have a look at this image. And here I've written this line of code, which just makes this image display a certain size within Jupyter Notebooks. So if we have a look at that, we have a visual representation of an array now. This is a photograph, but it's an array. And we can have a look at the shape of this array. And when we do, we see it's 536 by 800 by 3. So it's got 536 rows, it's got 800 columns, and then there is another dimension to this as well. And in fact, if we look at the number of dimensions by typing in the command that we know that works for that, we can see that we have 3 dimensions. So what that means is that we have 3 arrays of this size. So we've got 536 rows, 800 columns, and we've got that 3 times, repeating 3 times. And if we have a look at just one of those repeating arrays by doing this slicing here, and there'll be more on slicing and how to slice arrays in later tutorials, we can see what we get. And we can see that some of the color information is missing because we've only got one of those 3 arrays. That's a brief overview of NumPy. We're going to be looking at it in much more detail in videos to come. I hope you found this useful. If you have, please do like the video, subscribe to the channel, and I'll see you next time.